Hi, this is Ms. Kingsbury here, and we are going to walk through the lessons for this week. Your first lesson is to transform linear equations from standard form to slope-intercept. So I hope you remember working on slope-intercept form. We learned about y equals mx plus b so we could graph linear equations. What we didn't learn back then was how to use algebra in case we get an equation that looks differently, like this example, 3x plus y equals 6. If we want to be able to graph that, we can't unless we do something like transform using algebra and get it in this format, y equals mx plus b. We need our slope, we need our y-intercept if we want to graph this thing easily. So what we are learning is basically solving for y, get y by itself. You do have to kind of trick your brain because we're so used to solving for x. We aren't doing that. We are solving for y equals. So your first step is to move the x term by adding or subtracting, and we're going to do that together down here. We have this 3x. It's positive. We don't want it there next to the y, so we're getting rid of it. We're subtracting 3x from both sides. The 3x's will cancel over here, and then you'll be bringing down your y. You'll be bringing down your negative 3x, and you'll be bringing down that constant 6. Remember, you cannot combine your constant terms with your x terms. It has to sit like this, which actually is a good thing because if you notice, it is in y equals mx plus b form. If we had to graph this thing right now, we have our slope and we have our y-intercept. By the way, we didn't do the second step here, divide by the coefficient of y, and that's because our coefficient of y is positive 1. Is anything going to happen if I divide all these terms by positive 1? No, it will not. Example 2. Originally, before I got crazy on this slide, it said x minus 3y equals 9. And the reason that x is being canceled out is because, remember, we are solving for the y equals. All right, so this is the y term. We're going to leave it alone for a minute, and we're going to get rid of this x term. So it's a positive x. We subtracted it from both sides. We're going to bring down. So negative 3y comes down. The 9 constant term comes down, but please put your x term in front of your constant term so it's in the right format. All right, so this time we definitely have this coefficient. Remember, it's a negative 3. We don't want a negative 3y for our equation when we're done. We want a positive y. So that's why we're divided by negative 3. Yes, it's going to look strange like this. You have to show each individual term is being divided by negative 3. And then please be careful with your negatives. Negative 3 divided by negative 3 gives you this positive 1y. Negative 1 divided by negative 3. Yes, you can put 0.3 repeating here, but it's better if you leave your slope as a fraction. Remember, slope is rising and running, and it's much better if you have a fraction here than trying to use decimals. And then back here, of course, positive 9 divides by negative 3 and gives you negative 3. All right, moving on. Number 3 has a 2x. I believe that's a minus sign and a y, and it's supposed to equal 4. Our job is to get it to say y equals, so that's right. We are moving the x term. 2x, it's actually a positive 2x given to us, so that's why we're subtracting. Bring down, we've got this negative 1y. We've got our negative 2x that we're going to put in front. We're going to save that constant term for the end. And yes, we are dividing by the coefficient of negative 1 this time. So this time we're lucky, it cleans up. We don't have to worry about any fractions when we're done. It's y equals 2x minus 4. So typically in the classroom, I would have you try a couple of these on your own, so that's what we're going to do virtually. I'm going to have you start taking a look. You've got question 4 and question 5. Give it a whirl. See what you can do. In the meantime, so I'm not talking, go ahead and just hit pause. And then when you're done working through the questions, obviously hit play so you can check them. Okay, so let's see how successful you were with the next couple examples. For question 4, did you move the 3x term? Did you bring down the 5y? And did you remember to keep the x term separate from the constant term? If so, good job. And the second part of this solving is that you still have this coefficient to the y term. So did you remember to divide by 5. My dog is barking. Sorry about that. All right, so over here we've got negative 3/5, and that's going to stay. We've got negative 10 divided by 5. Sorry about that. My dog hears anything, and he thinks that everybody needs to know. All right, so I think we're set with this example 4. If you have questions, please let me know. I apologize. Obviously, I got distracted, and here's number 5. So 3x minus the y term equals 15. Yes, you had to move the x term again. Look carefully. Negative 3x, this plus 15 should come down, and yes, you have to divide by negative 1 all the way across this time. So y equals 3x minus 15. Let's see, number 4. Oh, right here. I did want to point out to you that this negative 3, remember when you divide by 5 and it does not come out even, you're best leaving that as a fraction. We don't want any decimal values here. That's your slope. It's very hard to rise and run with a decimal slope, so that's why we like fractions. All right, so moving on. The second page of notes I prepared for you guys, I called it Target 2. This is making sure that you remember how to graph a linear equation, even if I give you the formula like this. So let's remember, in order to graph an equation, we need it to say y equals mx plus b. Well, we can't get our slope and our y-intercept directly from a given equation when it's not in that format. So that's why that's step 1. You have to make sure you're transforming first and then graphing. So again, we're going to do a couple of these together, and then I'll have you pause the video, and then I'll have you try the rest of them on your own. All right, so let's see. Example 1, we had this 2x plus y. Remember, you're going to move that x term over. This one was nice because our coefficient to y was just 1. Don't bother dividing by 1, guys. It doesn't change anything. Now, this is where we need to review graphing. If it's been a while for you, remember that we like to begin with b, the y-intercept, plot that first, and then we move with our slope, our m. So down here, I just have this quick reminder, beginning with b. Yes, this is your b value down here at the end, y equals mx plus b. It's positive 7. So guys, make sure you're on the y-axis and make sure you plot your first point. Let me see if I can grab my red pen. Oh, my computer is super slow. I apologize. There it goes. And that would be your beginning point. Okay, from here, we need to remember how you move with your slope. Your slope is negative 2 over 1, which means you are going to rise down 2 boxes, and you're going to run. Always run to the right when we're running to the right 1 point. All right, this was a whole number. I know that, guys. That's your slope, negative 2, but we always put a 1 under a whole number. Dividing by 1 doesn't change the value, but it definitely gives us a rise direction and a run, or a number that you can rise and run. So again, I'm going down 2 over 1. You're going to extend this all the way across your paper, and this will give you an accurate set of points to connect your line. So please use a straight edge, whatever you got laying around at home. Put arrows at the end, and then label it. Okay, it has to be labeled. Don't forget to label your x and y axes if those are not labeled on your graph for you. So, graphing, again, it's a review, but what's new is transforming the equation so that it says y equals mx plus b, and that is what we want you very, very good at. All right, example 2, we get some fractions going here, so let's double check. We've got a positive 1x minus 4y equals 8. We're moving this 1x term over, so see how we subtracted it. And then when you bring down, we've got negatives everywhere. Be careful. Negative 4y, this negative 1x, this positive 8. And then we're dividing by negative 4 all the way across. So yes, we are going to have a fractional slope value right here. Just leave it 1/4. Remember, a negative divided by negative turns positive. 8 divided by negative 4 is negative 2. That is our beginning point, remember, our y-intercept. So negative 2 this time. Let me grab a different color pen. Negative 2 is our beginning point on top of the y-axis. Remember, 2 boxes below the y-axis. And then it says we have a slope of 1/4. And remember, slope is when you are rising and when you are running. Real quick reminder, We learned about slope dude, right? Nice negative. We have a negative slope, so it should be going downhill. You always look at your graph like you're reading a book from left to right. What's going on with this line? It's going downhill. This graph has to go uphill when we're reading the graph left to right, so we will be starting at our beginning point. We are rising 1 and we are running 4. Rise 1, run 4. And if we reverse the pattern, we can get ourselves across the whole page. And I goofed up on this point right here, so watch out. 1, 2, 3, 4 it should be. So again, straight edge. Maybe it's going to let me. There we go. Get your straight edge on there. Get your arrows on there, please. And your equation. I lost part of my equation. 1/4 x minus 2, it should say. Okay, so hopefully that's enough reminder. You've got, I believe, a couple more questions that I prepared for you. Question 3, 4 and 5. Very good, very good. All right, so click pause, and that way it'll give you a couple minutes to try the next couple questions. When you're happy, go ahead and hit play again, and you can check your work. Okay, ladies and gents, did you remember to transform your equation correctly? This 3x you had to move. You had to divide by negatives all the way across. I ran out of room because I wrote really big. So let's see. I ended up with the equation y equals. I had a positive 3 slope, and I had a negative 5 y-intercept. Let's see if we agree. Beginning point, negative 5. Okay, I like it. And let's see, did I rise 3, run 1? Rise 3, run 1. Yes, it looks like we are in good shape with this one. Remember, if you ever have any questions, just let me know. Check my email all the time. Way too much, actually, but that's okay. All right, so number 4. We have 2x. We're moving. We're dividing by 5. Remember, this comes out to be a decimal, but we don't really work with decimals well when we rise and we run. So you'll notice I left it as a negative 2/5 slope. And back here, it looks like we ended up with a negative 2 beginning point. So I believe that is on, and again, I ran out of room because I was writing too big, so I apologize. Look over here. Y equals negative 2/5 x minus 2 is my finished equation. And let's see if I correctly went down 2, 1, 2, 3, 4, 5. I did down 2 over 5. Remember, nice negative is your slope. And last but not least, you had to move a 5x. You had to divide by this negative 1 coefficient. And we end up with y equals 5x minus 10. This one's very, very steep. Negative 10 is your y-intercept. We had to rise 5 before we can even run 1. So hopefully these points are accurate. Something looks funny on that one, but I think it's just my marker taking up a lot of space. So y equals 5x minus 10. You can now not only graph a linear equation, but you can transform it to get y equals mx plus b form. Super important skills, guys. Next week, we're going to work on graphing linear systems. So really good that you practice this stuff this week. Let me know if you have any questions. I can work with you to sort all that out. Thanks, guys. And again, sorry about my dog. He's very good watchdog, I guess you could say.